Okay, so you've already learned how to take a simple random sample when we looked at the rectangles. Now we're going to learn how to take different types of random samples. So we're going to go to how much do fans love Taylor Swift? If you go to statlet.com, all right, and you scroll down to activities, boom, there it is. You can just click on that link. I'll put one in the lesson. We're going to do this one independently since you were not here for class. And first method we're going to use, well, first of all, let's look at the scenario. Taylor Swift wants to find out how much fans enjoyed the Eras tour shows. She will ask fans from 1 to 100, where 100 is the most, how much did you enjoy the concert? The VIP section she wants to survey has 50 seats, 5 rows times 10 columns. The stage runs along the northern edge of the venue where Taylor is pictured, and she wants to take a sample of 10 fans. Well, actually, she wants you to sample, but that's what we're going to do. So here's the good news. In this app, it's just clicking a button. So there is a simple random sample. And let me go ahead and highlight my sample here. So this is actually on the left here. I've got my um, where your activity is in your packet. All right. And I have these little seat numbers. By the way, these have the actual enjoyment just because it makes it easier if you want to actually add these up. 2, 3, which I would. I used to have you guys manually add them up. But luckily on this activity, it's pretty good about doing the averages for you. So there's a simple random sample, right? And yes, okay. So let's go ahead. And I'm going to do a stratified sample by row. So if you're going to the next one, you can see stratified by rows. So we're going to take this sample here and we're going to mark it on our packet. So just go ahead and generate all your samples. We'll have, let's see, 1, 2, 3. We got this guy and this guy. And then we got these two and that one. And then we have that one and that one. There we go. Almost there. And these two. And skip two. All right. So there's my stratified sample. And then finally, we have one last one, stratified by column. So there's my sample there. Let's go ahead and get this. So we have this guy, this guy, this guy, this guy, this guy. I can skip over there, get down here. And then these two. Oh, I missed the 6, 7. Sorry, Adam. Anyways, so now we have all our samples. So we're going to reveal the results, which has your data. So actually, I'm going to go ahead and record the averages. So my average for this one was 78.1. Let me go ahead and put that in. 78.1. Then we'll scroll up. My average for this sample, let's see, yeah, 79.7, 79.9. And then finally for my simple random sample, 79.3. So they're all pretty close to each other, it sounds like. All right. Sounds like Taylor Swift could use some work. So now let me go ahead and look at our questions here that we have. First of all, one of the questions we should have is how do we take a sample? Well, hopefully you remember that in the rectangles activity, we numbered our rectangles. So is 92 the number of my person right there? Well, actually, what I would probably do is number the seats from 1 to 50. So I go, 1 and then 2, 3, and then I get all the way to 10 over here. And then I'd have 11 on this seat number here and 12, etc. You get the idea, right? So I would number all the way, and this would be seat 50, which I picked. Oh no, Adam, I missed the 6, 7 seat again. All right. So you can see that. So I numbered them all like we numbered our rectangles. Then in the rectangles, we use technology. We use the random number generator, which is a great way to do it. But one of the most foolproof methods to random sampling is using a hat. Or, as some teachers like to teach their kiddos, use a sombrero. So, anyways, you number the seats from 1 to 50. So you have to number the individuals, all right? Then you put the individual identities, in this case, their seat numbers, on slips of paper, all right? Uh, Now, I wouldn't have their satisfaction because I haven't surveyed them yet. So I don't know the 92 and the 89. I only know the ones that I actually surveyed, okay? But so I have to pick them first. So I cannot have these numbers on the slips. I need to have their seat numbers on the slips. So I put the seat numbers in a hat from 1 to 50, put them in the hat. Now, if I put them in order, let's say I go 1, 2, because it makes sense to do it in order so I don't lose track, right? And then I just put them straight in the hat, but I don't mix, then I'm probably going to be pulling from the back rows when I pull from the hat because those are going to be the slips of paper on top. So make sure that you mix well, all right? Then you pick 10 unique slips of paper. So you don't want to be surveying the same person twice. Taylor Swift's going to look at you and shake her head. Why are you surveying the same person twice? She wants 10 different people, right? So we need to say there are a couple ways to do it. I actually overdid it here, which is fine. I said unique. That really is a great way to say that I'm not going to have the same person twice. The other way you can do it is without replacement. So I could have just said 10 slips of paper without replacement, or I could have said 10 unique slips of paper. I included them both here. It doesn't hurt to have them both. And so you have both examples. All right. So let's go ahead and look at our sample again. Where is Taylor Swift? I'm on part 1. Oh, she was on a different tab. Come back, Taylor. There you are. So now what we're going to look at, I'm going to actually put her back here so we can come to her more easily. Is it possible to get 3 fans in a row? Actually, I did. How about no fans in a row? Well, in this sample, I did get fans in every row. Does that mean that's going to happen every time? Well, luckily, we can generate some samples. Oh, see, I didn't have any fans in that row. So it is possible not to get fans in a row, or see, I got a couple of columns that don't have fans. Here's another time I missed a row. Let's see. Usually I tend to get some in every row. Oh, front row. I missed the whole front row. That's going to be a low satisfaction sample, I'm pretty sure. So when we go here, is it possible to get 3 fans in a row? Sure. How about no fans in a row? Sure. Why? Because we're not using rows to sample. All I'm using are seat numbers. All right, how about 3 fans in a single column? Not this one. Let's try another one. Not there. I got fans and I got 3 columns without any fans. There we go. We got 3 fans in a single column. So yes, we can do that. Why? Because we don't really care about columns. We're not using columns to sample, just seat numbers. And here's an interesting part. So if we go here, is it possible to get, say, these 3 fans together, or a group, let's say 3 fans together that are right next to each other? Almost there. Oh, I had one on the previous one. Did you see that? Those two, almost there. Let's see if we can get another one with 3 together. Just a lot of clicking. I got to be patient because I'll click too fast like I did because I already, there's one. So yeah, sure, you can get 3 fans right next to each other, or you can get 4 fans in a column. So in simple random sample, they can be anywhere, any group of 3 fans. You can pick any 3 fans here, and it's possible to get them together. Is it likely? Well, that's another matter. That's probability because there are a lot of ways to gather a sample like this. Okay, now let's go to stratified by rows. So when you look at the sample, let's take a look at a couple of samples. All right, so we'll go to stratified by row now. So one thing you should notice, you're probably noticing a pattern here. Am I able to get, I think one of the questions I asked, 3 fans in a row? Let's try. No, looks like every time, every row has 2 fans. All right, so what does that mean? What are we trying to do when we get this sample? Looks like we're trying to get an equal number from every row. Okay, so we want some of each row. No matter what we do, we get 2 per row. Okay. So how would we write instruction? Well, let me go ahead and answer the questions. So is it possible to get 3 fans in a row? No, because we're getting exactly 2 fans from row. Notice, by the way, since we're right here, can I get these 3 buddies together? No, because it's constrained by the row. So not all groups are equally likely. So you're probably going, well, why is that important, Mrs. Silverman? You're going to find out that the definition of simple random sample is that all groups of the same size are equally likely. And wink, wink, nudge, nudge, this is an important concept that you will be tested on. Okay. It shows up on my test. It probably shows up on the AP exam. Okay. But see here, not all groups of fans are equally likely. So I'm going to make a little note. This is tested. All right. I'll just add it in here. And this is a tested concept. So, in my test and AP test. All right. So let's get back to our stratified. And then once I say no here, I could actually say, okay, I can do the same thing here. And I'll put it in red. There we go. Thank you for letting me be weird and mark my text. So here, there we go. Is it possible to get 3 fans in a single column? So let's look. Generate new sample. Yeah, you can get 3 fans in a column. Why? Well, here we had 92 and then 89. It was okay to have the first seat picked again because it wasn't part of the constraint. I'm taking a new sample on each row. Okay. All right. And then that means since, even though, actually, I'm going to get rid of that. There was a reason I didn't have it there. So if it's not, so this one doesn't really contribute to not all groups of fans are equally likely. This one does. So I can't get 3 fans in a row. That breaks the concept that I can get all of the groups. Can I get 3 fans in a column? Yes, but I can't do 3 fans in a row. All right. So how do we do this? So it's like we're taking 5 samples. All right. So it's like you're doing an SRS 5 times. So I'm going to add that as a note. It's like taking 5 SRS, simple random sample, the simple random samples. So we're doing 1 for each row. Okay. So we number seats in each row from 1 to 10. Write 1 to 10 on slips of paper and put the slips in a hat. Mix the slips in the hat well. Pick 2 unique slips of paper without replacement for your 2 people in each row. Put the slips back in the hat and then repeat these 2 steps. Mix it again and draw 2. Write them down. Put them back in the hat. Mix again and draw 2. And you just keep doing that for each row. Okay, now let's go to the next one, which is stratified by column. So you can see here, oh, I don't have anybody in the front row. And that's going to be a low sample. I have no one in row 2. So it's actually, it's pretty common. Can I have 3 in a row? Oh, let's see. I got 4 in that row. So you can see rows don't matter. But what is true for each column? We have 1 fan in each column, right? So I just keep generating. And I always have 1 fan for a column. So how are we going to do that in terms of sample instructions? Well, you would just, instead of numbering the seats in the rows, you number the individuals in the columns. Okay. So your strata is what you're taking a sample of. So stratifying is like taking multiple samples. You can see it down here. And we get some individuals from all of the groups. All right. So we number the seats from 1 to 5 in each column. Seat 1. So if I did this, seat 1, seat 2, 3, 4, 5. And then I would do the same thing here. This would also be 5, and that would be 1. That would be 2. So let me do a 3 so you know, and a 4. So you get the idea. We number them, we number them in each column. And then we write down 1 to 5 on slips of paper, put it in the hat, mix slips in the hat well. We draw 1 slip of paper, and we're done because we're only getting 1 per column. Put the slip back in the hat, mix it again, and then draw again until you get all 10 columns represented. So stratifying is like taking multiple samples. Notice how you have to put it back in the hat and mix well, and then take another sample. Put it back in the hat, mix well, take another sample. The individuals in strata should be similar in some way. So let's go ahead and look at the dot plots, because let me go actually back here. So we can actually add a bunch of samples. I'm going to just add 1,000 to each one. So adding 1,000 samples to my simple random, to my stratified, and to my column. So I can get nice, pretty graphs. All right. So let me actually zoom out on this a little bit so you can kind of see them together. Yeah, that's not working so well. We'll go to my activity because I have them already copied down back here. So here are the three we just did: simple random, and then stratified by row and stratified by column. If you were looking at them, you can tell one does a better job than the other of getting samples, of getting the average, the true average. So it does a better job of capturing your highs and your lows and everything in between. So if we look at our samples, which one is better at capture? Oh, I forgot to mark my samples here. Oh no, because I haven't taken that sample. So we have stratified by column. This one, if we go back to the Taylor Swift activity, stratified by column, is it possible to get samples that are more positive? Like this one's pretty positive. You got a lot of people in the front and just a couple of people in back. This one's more negative. So you're not guaranteed you're going to get people equally in the front and the back. I don't really care about left to right. So when I talk about this activity, I like to ask people, what's the most you've ever spent on a concert ticket? And, the different answers, over $1,000 for some tickets. And I was actually asking like for assigned seating. The most I've ever spent for a concert ticket, and this was like 20 years ago, it was a Prince concert, and I paid over $300 a seat. This is over 20 years ago. And I even bought a seat for my husband, and we drove to Houston and we watched the concert. I was on the floor on the 12th row, and I had a fantastic time, and I do not regret one penny of it. It's a good lifetime memory, right? Actually, and I was lucky enough that I was 18 years old in 1984, and I got to go see actually it was 1985, and I got to go see the Purple Rain concert by Prince. In my opinion, Prince is the best musical artist ever, best Super Bowl show, has a huge number of number one hits, written number one hits for other people, can play almost every instrument there is, well, when he was alive. So you can argue with me if you want. I mean, there are many great artists, but I don't think Prince, at least in our era, has an equal. So there you go. So my point is, what was the point of all that? My point is that people in the front row tend to be super excited. They're willing to pay the money. If we look at the census, let's look at the census. See how many, well, we got this one person, 2, 3 people below a 90, which is kind of a shocker. I had the feeling Taylor's numbers are higher. And then back here, these are all the glum people who are like, I came because I feel like I should come, but I don't feel like spending the money for the front seat. So that's why it's important to, when you do strata, that they are somehow homogenous, that you're trying to get different levels. So like if I was surveying high schoolers, then I would want to make sure I got freshmen and sophomores and juniors and seniors, because seniors are definitely different than freshmen, which are definitely different than sophomores. So you want to get some representation from all. Let me go ahead and add that as a note. All right. So stratified is some representation from all groups. Does that make sense? Okay. So then let's go ahead and we're going to take a look at clusters. So we're going to have to look at Taylor Swift Part 2. Again, there's a link. Do the activity individually. And then we're going to, there's your simple random sample. We won't need that one. there's your cluster sample, and there's systematic. The reason I don't put this one on here, it's like it randomly chooses and then it wraps around, which is really just kind of wonky. I'll show you what that one looks like. And I'm like, ugh, I would never use a systematic sample for this thing because, like I said, it's just too wonky. All right, let me go ahead and go back so I can go to here and copy my sample. So let me go ahead and copy my sample. This is, I want my cluster. No, I don't want systematic. That's wonky. Here's my cluster. So my cluster, I start with the guy in, I'll do purple again because of purple rain. There we go. So I'm actually just getting the whole group. I don't even have to dot them individually. I'm just picking 2 groups. Why am I picking 2 groups? Well, I want 10 fans, right? And if I'm clustering by column, then I would need 2 columns. Now, I could just pick one row, but there is a problem with picking one row. If I pick the front row, I'm high. If I pick the back row, I'm low. So that would tend to be not a good thing. It's not really biased. It's just very variable, very wacky. Well, let me go ahead and get my average down before I forget. I'm like, oh no, I forgot to write down my average. I might have to calculate that by hand. That would be a travesty. All right, 76.3. All right. So that's if you add up all those seats, um, that's what you would get. Let me go ahead and show you a couple more clustered samples. You can see this. So here, again, we're just picking columns. And so it's not possible for me to pick 3 buddies in the front. All right. So that's an important thing. Is it possible to get 3 fans in a row? No. How about no fans in a row? No, because I'm picking entire columns. I'm automatically going to slice up the rows. All right. So we are selecting 2 columns, so that would be 2 people per row. Additionally, is it possible to get 3 fans in a single column? No, we're either getting 5 or none at all. All right, depending on whether the column is selected. So because I cannot get any 3 buddies I want, let's actually let me come here and get a different color. I can't get any 3 buddies. So like if I wanted these 3, that's not possible. All right, so let me get rid of those in case you think they were sample or something. So not all groups of fans are equally likely using clusters. Again, going back to that important definition, which will be tested. Simple random sample. Not only is it, and I'll talk about the probabilities here in a second. All right, so how would we write instructions for this? Well, our groups are the columns. So we're going to number the columns from 1 to 10. Put numbers 1 to 10 on slips of paper, put in a hat and mix well, and then pick 2 unique slips of paper without replacement to select your 2 columns, and you're done. Okay, you would survey everyone in those columns. In fact, let me go ahead and add that in. Survey everyone in those columns. So actually, I could say all 5 seats since we had seats in each of those 2 columns. So you're picking 2 groups, right? So here, stratified is some representation from all groups, and cluster is basically sampling all individuals in some groups. That's what cluster is. So some people say stratified is sum from all. All right, let me just write sum from all. Okay, so we get sum from every group, and this is all from sum. So we get some of the groups, and we sample them all. So cluster sampling is doing sampling of groups instead of individuals. We get 1 sample of groups and take data from all individuals in the selected groups. Clusters should look like a snapshot of the entire population, and each snapshot should be similar. Which is more representative of the population, one of the rows or one of the columns? Well, the columns are because you have people with high satisfaction and low satisfaction in the same column. So you take a little slice this is a little slice of Taylor Swift fans. And then finally, so when I go ahead and gather a lot of them, you can see there's my cluster by column sample. And which method shows the most bias? None of them. Are they all centered around the true mean? Yeah, they're all pretty much centered. This one's a little wonky, and I'll talk about that in a second. If you have the least variability, I would say this one does. It's most tight, so stratified by row does, because it's most tightly packed around there. Okay. And which one would you use? Then actually, cluster by column is not too bad. Remember, it's actually getting pretty representative groups. Um, and then which one would you? I would personally tend to, if I was actually doing it, I'd be tempted to do a cluster, although it would be hard to walk from row to row. Depends how the seats are. But usually stratified is the hardest, and the cluster samples are usually the easiest. So if I sent you, say, to the cafeteria and our cluster, our groups there, let's say groups, because we're not necessarily doing clusters, our groups there are tables, all right? I could sample some of each table, where I would go up to each table, roll a dice. Let's say there are 10 shares per table, and I roll a 10-sided die until I get somebody. Then I go survey. And I go repeat that all across the cafeteria. All right. So I'm taking, who knows, dozens of samples. Or if I had all the tables numbered instead of the seats, then I could say, okay, let me just do slips of paper or a big enough die or something, or random number generator, and pick, say, 4 tables or 5 tables. Actually, you're probably going to do more like 8 or 10 tables, depends. And then you go to those selected tables, and then you just interview everyone at those tables, and you're done. Okay, so cluster sampling is the most popular just because it's easier to do, and I don't blame you for that. Now I have some interesting notes. This is primarily for my AP kiddos. So if you're in my regular stats, I haven't taught you some things yet. So just for the fun of it, I went ahead and I calculated how many ways can you draw a simple random sample for the Taylor Swift VIP section. So the way I did this is simple random sample. This is, let me go ahead and modify it. There are 50 people to choose from, right? And we're choosing 10. Or let me make sure these numbers are right, because I did do it pretty quick. So if you go to counting methods on, let me show you on the Staplet, it has counting methods. We're doing combinations. So if you've already learned about binomial distribution, so we've learned about combinations. I have 50 people to choose from, and now I'm going to do the combinations, and there it is. Yeah, that looks like the right number. So what number is that? That looks like 10,272,278. I'm sorry, 272,278,170 ways to choose 10 people from 50. Each person has a 1 in 5 chance of being selected. And they can be selected from any, every group of size 10 has an equal chance. Yes, I'm going to be very particular about this because I want to make sure. Where's my red? There we go. Every group of size 10 has the same chance of being selected. All right. So now, admittedly, it's a 1 in 10 billion chance, but it's all the same. All right. Any group is possible. Stratified by row, we learned that that's not true here. Okay. And so what I'm doing is picking by row. So if I do, if you go to the counting methods again, I have 10 people in a row. I'm going to pick 2. Combination is 45. All right. And so I would go back here. Let me go ahead and just put this in. It's 10 choose 2. And actually, later, for my regular stats kiddos, you're going to recognize that and use that app to count things. Let me make this so that it's not. There we go. That's fine. It's fine. There we go. Okay. So each person still has a 2 out of 10 chance being picked in their row, right? Or 1 in 5 chance being selected. So each person still has an equal chance of being selected, but each group doesn't have an equal chance. Do you see that? So each person has an equal chance, but not every group has an equal chance. Let me see if I can do this in red. So actually, maybe let me get this. That didn't work. Sorry, guys. I'm just trying to space it out. That's not looking good. Actually, no, I'm going to do this. And then this. This will probably help. All right. Maybe that. There we go. Yeah. Let me just slide it. There we go. Now we fit. Thank you for being patient with me. So, but not every group has an equal chance. Okay. So that's stratified by row. You don't really have to write this stuff down. I'm writing this down because I just want you to see the math behind the sampling. This is actually part of the unit G, or as I like to call the OMG for AP Stat students, when we go into sampling distributions. So when I calculate how many different ways there are to pick people, if I had every possible way, then I would have the entire sampling distribution. Here, I just have sort of a sample of a sampling distribution. I have a lot of them, but not. I don't have 10 million samples in here. All right, column. There are 5 to the 10 because I'm just picking columns. So I have 5 choices for the. I think I did that wrong. I'm picking stratified by column. Oh, that's right. So I have 5 seats in each column. So I'm going to go 5 choices in the first column times 5 choices in the second column times 5 choices, etc., 10 times. So that works out. Let me put my commas in to be a little less. Only 9 million ways to pick by stratified by column, right? And so you can see that each person still has a 1 in 5 chance because you come to the column and you come to the person, they're 1 in 5. But you can't get 2 buddies in the same column because it's stratified by column. Not every group has an equal chance. Not every group has an equal chance. Cluster by column. This one's actually, and that's probably why this graph is so wonky. All I'm doing is picking 2 columns out of 10. So 10 choose 2, if you go to the counting methods, which we just did, is 45, right? So there are only 45 ways of picking columns. All right, now let's go to these questions down here. Which method shows the most bias? None of them. They are roughly centered around the true mean, okay? None of these are biased. If they're random, they're probably not biased, okay? Well, let's see if I can move that up. All right, so none of them are biased. Least variability, stratified by row. Probably the most precise, probably stratified by row, but if you really wanted to make a cluster, you could probably do cluster by column. So hopefully that was very helpful in learning how to take samples. There's a lot to it. You really have to do it to learn it. All right.